Okay, we're going to talk about chapter 6.5, page 390, absolute values. Now, I've mentioned absolute values to you before. Basically, with an absolute value, it's neither a negative or positive. It's always a positive value, let's just say that. It's never negative, and it's a distance. It's like our distance on the number line. Like, for instance, here, we will say that positive 4 is 4 units away from 0, and negative 4 is 4 units away from 0. It's kind of like if I say, okay, I'm going to go to the mall, and the mall from my home is 10 miles. Well, if I say, well, what is the distance of your home from the mall? Then you would say it's 10 miles. It's not negative 10 miles. So it's 10 miles to the mall and 10 miles back from the mall. So we never express distance as a negative value. So that's how come we say the absolute value of a number is always a positive value, because we're representing distance. For instance, we see the absolute value of x is equal to 7. So therefore we know that x can be positive 7 or x can be negative 7. So now what I want you to do is stop the video for just a second and try the guided practice number 1 on page 390. Okay, so now you've started your video back up, so this should have taken you but just a couple of minutes. Here we see that x is positive 3 and x is negative 3. If I graph that, we would see, let's just say from 0, positive 3 is 3 units from 0, and negative 3 is 3 units from 0. And then the same thing with 15. X is 15, x is negative 15. Now we're going to talk about how to solve an absolute value equation. So what I'd like for you to do is look on page 391 at example 2. Here we see the equation x minus 3, or the absolute value of x minus 3 equals 8. Now I want you to notice we represent absolute values with two parallel lines to each other. Okay, so they're standing straight up, and we call those parallel lines. And we put our value in the middle of the two lines. Now, to solve the equation, the way we would set this up is we're going to take what's in between the two lines, x minus 3 equals 8, and then x minus 3 equals negative 8. So we have to set it to equal the positive value of 8, and then set it to equal the negative value of 8. Now take a second and just look at that. Now what I'm going to do next is I'm going to solve this equation, and we're going to do that, of course, by using our addition property of equality and adding 3 to both sides. Okay, so we have x is equal to 11 and x is equal to negative 5. And you would see here, I could put these in, substitute them in. We would say, okay, 11 minus 3 equals 8, and then negative 5, negative 3 equals negative 8, so it does in fact work. Sometimes we can also have multi-step absolute value equations. So what I'd like for you to do is look at example 3 at the bottom of page 391. Here we have 3, and then the absolute value of 2x minus 7 is, and then a minus 5 equals 4. Now notice how I have more than just the absolute value on the left-hand side of the equal sign. Now, we're going to solve this just a little different. Be careful, because the temptation here is to treat these like parentheses, but they're not. And we're not going to treat them that way, so we're not going to be doing distribution or anything like that. What we're going to do is we're going to get this absolute value and everything in between the absolute value signs here by itself. Okay, so we're going to treat it just like it's a variable. We want to get it by itself, and we're just going to follow our properties of equality. So the first thing I'm going to do is I'm going to add 5 to both sides. Okay, so now we're going to bring down 3. Absolute value of 2x minus 7 equals 4 plus 5, which is 9. Of course, that cancels. Now my next step, because normally we would look at multiplying 3 times 2x minus 7, but remember this is absolute value, we're not going to do that. We're going to divide. So it'll cancel. And then of course 9 divided by 3 is 3. So now we have the absolute value of 2x minus 7 equals 3. And now we're going to solve it just like we solved the equation in example 2. So I'm going to set it up as 2x minus 7 equals 3, and then 2x minus 7 equals negative 3. Okay, and I'm simply going to solve that by adding 7 to both sides. I'm running out of room here, so I'm going to come over here. We have 2x equals 10. And then we're going to add 7 to both sides here. And that would be 2x is equal to, of course that would cancel, negative 3 plus 7 is equal to 4. And then we would divide both sides by 2 in each case. And x equals 5 and x equals 2. So our answer is 5 and 2, and that is correct. So what I'd like for you to do is stop the video and work the guided practice. Okay, so hopefully you're back. You were able to work the guided practice. So I'm going to work through these problems very quickly in our guided practice. The first one we have is the absolute value of r minus 7 is equal to 9. So what I'm going to do is we're just going to write it out. R minus 7 equals 9. R minus 7 equals negative 9. Add your 7 to both sides. This will cancel. R equals 16. We'll add 7 to both sides here. R equals negative 9 plus 7, which is negative 2. So our answer should be 16 and negative 2, and hopefully you got that. Okay, now the next one, number 3, we have 2 times the absolute value of s plus 4 is equal to 18.9, and that's 4.1. So the first thing I'm going to do is I'm going to subtract that 4.1 from both sides. So hopefully you did that first. So to cancel, and then 18.9 minus 4.1 is going to be equal to 14.8. Now my next step is we're just simply going to divide everything by 2. Okay. So now we're going to take the we're going to take the 14.8, divide that by 2, okay? And then we get 7.4. So s is equal to, the absolute value of s is equal to 7.4. And then, of course, the way we would handle that is it would be equal to positive 7.4 and negative 7.4. So notice we had to get the absolute value by itself, first of all by using the subtraction property of equality, and then using the division property of equality. Okay, and then our last one, number 4. And then number 4, we also have a multi-step where we have 4 times t plus 9 is, or minus 5, equals 19. Once again, we're going to have to use the addition property of equality and add 5 to both sides. 4 t plus 9. 5 cancels. 19 plus 5 is 24. Now we're going to divide everything by the 4, and we get t plus 9, and then 24 divided by 4 is 6. Don't forget your absolute value signs. Now we know we're just simply going to solve this by setting t plus 9 to equal positive 6 and negative 6. Okay, so the absolute value of t plus 9 equals positive 6, and then the absolute value of t plus 9 equals negative 6. And then we're simply just going to solve it. I'm going to subtract 9 from both sides, and we get t equals 6 minus 9, which is negative 3. Subtract 9 from both sides here, and we get t is equal to negative 15. So our answer for number 3 in the guided practice is negative 3 and negative 15.